The Evolution of Medicine, a Genius Hour by Natalie. In the early years, science was not involved in medicine. Medicine was based on religion, and people used herbs and plants instead of x-rays and PET scans to heal people. Here you can see a photo of the first physician known by name in history. His name was Imhotep, but I'm not sure if that's how you pronounce it. In our modern day society, we have technology that can heal people better than herbs ever could. For my Genius Hour, I focused on learning how some of this technology works. In this project, I will talk about how an X-ray, an MRI, and a PET scan work, and especially how they can help to heal people. In the year 1895, scientist Wilhelm Röntgen discovered the X-ray. An X-ray is a concentrated electron beam with a very short wavelength, and it is so short that we cannot see it. However, the X-ray is able to pass through human tissue and organs. Our bones are able to absorb the X-rays, which is why we see an image of our bones in a stark white color. The X-ray machine works as a circuit does. The cathode contains the filaments, which are heated and positively charged. The anode is negatively charged. The two have a potential difference. And as we remember from physics this year, a potential difference leads to a current. And the current of the negative electrons flows in the X-ray machine's circuit. And then whatever substance the cathode is absorbs the electrons and then releases energy in the form of X-rays. These X-rays have a high frequency and a very short wavelength. PET scans, or positron emission tomography scans, are used to produce three-dimensional images of the insides of the body. These scans can help in detecting tumors and determining the conditions of the body. PET scans work by detecting radiation in your body that is given off by a radioactive tracer that is ingested prior to the scan. The tracer is called fluorodeoxyglucose. The radioactive tracer causes the cells in our body to give off positrons, which are positive electrons, and this positron will create two gamma rays, and the rays will both have momentum. According to the law of conservation of momentum, the two rays will travel in equal and opposite directions. The scan is then able to detect both the rays and then pinpoint the location of the nucleus which gave off the positron. The MRI scan. MRI stands for magnetic resonance imaging. Within the MRI machine, there are many moving electrons which creates a magnetic field. Then the magnetic components of the protons within the water molecules of our body align with the direction of the magnetic field due to a radio frequency pulse from the MRI. The changes in magnetization cause a change in magnetic flux. Then the protons in the tumors return to an equilibrium at a different rate than protons of normal cells. And this is what creates a contrast in the image produced by an MRI, which helps doctors to determine the locations of tumors. For more information, you can check out the websites here on the Works Cited page. But for even cooler information, you can check out the work on my cool blog. As always, thank you for watching and see you in class.